Hey class, we're back at it here in 6.1. This is a problem where we have raw data and we want to construct a confidence interval. So this is commute times from home to school for all ARC students. Well, here's a sample of some students, and we're going to use this sample, 36 students, to estimate the commute time for all students. So the first thing we need to do is load the data into StatCrunch. I put this data set in your folder. That was from last one. So if you go into my groups, hopefully you've joined my group, and then C1000, and we got to go to the end here. There it is, the commute times. Click on that, and we got the data loaded in. Okay, so now this is the raw data. So we're going to go to the same location as last time. We're going to get stat, ZStat, one sample, but now we have with data, right? So we're going to choose that first choice. And now we just got to show where it is, right? So it's commute time, right? So we put that in there. And we do have to put in the standard deviation because it is given in this problem. It says that assume the standard deviation is 12.2. So that's critical. If we don't put that in there, it'll just use the sample standard deviation, which we don't want. Right, so make sure to put that standard deviation, even though it says optional there. Okay, and then you can skip those next two. We're doing the confidence interval though, and this one we're doing a 90%. So I'm going to change that to 90, and why not show the critical value? And that's it. Okay, so it should be good. Okay, and then we get the values, right? So this is about, I guess if we did one decimal place, 18.0 to 24.7. And we even get the sample mean there, 21.3, right? So all that is useful. But let me jump back to the handout and I'll write that down. Okay, so that's it for that one. Right, just a little technique from StatCrunch. This is where StatCrunch, I think, is really useful, is when you have this raw data, right? Because we wouldn't want to have to do all that by hand, where we would need to calculate, the sample mean, etc., and all those numbers. So StatCrunch is very helpful. Now, when you're doing this, though, in my lab, it might still ask you for the margin of error, and it was never given to us when we did StatCrunch, right? The margin of error is not there, but I do know how to find it, right? Remember, the margin of error, a good way to think of it, is always the sample mean minus the lower limit, right? It's that distance. Okay, so if you look back on that StatCrunch, we were given, I remember it, it was 21.33. It gave us the sample mean on the output. And then that lower limit, more precisely, was 17.99. Okay, so this is about 3.3. So that's how I would tackle that margin of error. If you're using all StatCrunch, you didn't really find the margin of error with the formula or anything, you can kind of back work it using the end result and just subtract the sample mean minus the lower limit. Okay. Now, what if we crank up the confidence here? Right. The first one we did was a 90%. This one, what about 95? Okay, so I can go back to my. I'm going to go option edit, right, and I'm just going to change that level of confidence to 95, and then I'm going to compute. Okay, and that changes it. Right now our lower limit is 17.3 and upper limit 25.3. So let's write those down. 17.3, 25.3. Right. Okay. Oh, okay. That's gonna. Well, how about we get more confident? What about 99? All right. We'll go back and change that. Do that same kind of thing. So a nice little feature in StatCrunch. If you click options, you can edit the previous page. Now I can just change that to a 99. Compute it, and now we're down to 16.1 and 26.6. Right? So 16.1. 26.6. Right? And the point of doing this is, the question is, okay, what's happening to the interval as we increase our level of confidence, but everything else stays the same? right? Is it getting wider or narrower, right? And we can see that what's happening is it's getting wider, right? Which I think makes sense because, you know, if you're going to be more confident, you want to have more values involved, right? The wider the interval, the more confident I'm going to be, right? I mean, if the width was super narrow, you know, you might end up being less confident. So as the confidence level increases, right, we see that it's getting wider. Okay. One more thing from 6.1 is finding a minimum sample size. So this is basically the margin of error formula, just algebraically manipulated to solve for n. So this is going to give us the n that we need in order to be at a certain level of confidence and a certain margin of error. Okay, so for example, number 7, you want to estimate the average age of students at A or C. So how many students should we survey, right? What do you think, 100, 500, 1,000? Well, this formula will tell us so that we don't waste time, right? This is just the minimum that we need to get the level of accuracy that we're looking for. Okay, so n equals, and I just got to plug in everything, right? What would be my ZC, right? The ZC, well, the ZC is based off of level of confidence of 95, right? So if your C is 0.95, go to that little table at the beginning. I don't want to page all the way back there, but if you do, it's 1.96, right, for your ZC. Okay, so my first value, 1.96, and then times the sigma is the next thing in the formula, and that says 8.7 in this problem, divided by, how about the margin of error? Where is that? Well, notice what it says, within 2 years, right? So there's a key word for margin of error. Anytime it says within, the number that comes after it, that's your margin of error, right? So that's how accurate we want to be. Whoops. Put the number 2. And then don't forget the square, the formula. Okay, and then just calculate that with your calculator, and this ends up being 72.69. All right, and since this is the number of students, we're going to round that up to 73 students. And a key for these is always round up. So always round to the next whole number. That ensures the minimum. If we round it down, we wouldn't achieve that minimum margin of error. Now, so again, I mean, like even if it were 72.1, we're still bumping it up to 73. So always round up to the next whole number. Okay, we can try one more. Collecting data. Let's see, blah, 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 blah. We got 95% confidence, right? Sample mean within, there's your margin of error. And we got the standard deviation. Okay, so we got that same sample confidence, 1.96. So my critical value is still 1.96. And here we go. N is, so 1.96 times standard deviation 5 divided by margin of error 0.5 squared. And if I get that, ends up being 384.16. So here's a case where we get something that's just slightly over 384. We're still going up. All right, so this is going to be 385 student athletes. Okay, and that brings us to the end of 6.1. So I'll stop there, and in the next video, we'll jump to the next section. Okay, hope all's going well. Talk to you later.